All right, let's take a look at factoring another polynomial here. And this one's going to seem a little bit different, but it's still factoring a trinomial. But in this case here, we only actually have two terms. We have the x squared and we have a 49. Now, the one little thing that we'll take a look at here is that they're both perfect squares. X squared is a perfect squared, 49 is a perfect squared, and we'll look at that in just a little bit. When we factor this one out, though, what we're going to do is replace the middle term, which is missing, right? There's nothing there, but we can think of it as a 0. So there's 0x minus 49. And now also we have a trinomial, which we can factor out. Okay? When we do this here, negative 49 is a combination of negative 7 times positive 7. So x squared minus 7x plus 7x minus 49. You'll notice here now this adds up to 0. We were just using decomposition as we to go through that. X squared and 7x is x. We're going to take out x minus 7. And then here we can take a 7 out, so it's going to be 7, and then x minus 7. Now this might seem a little bit similar to the previous ones where we had perfect squares, but this one is slightly different where we have x minus 7, and then we have x, that's a plus there, x plus 7. So they look exactly the same, except one has a subtraction and one has a adding symbol. Okay, this is what we call a difference of squares. Okay, they look exactly the same, except that they have different two symbols. One is subtracting, one's adding. The difference of squares comes in this here. We're subtracting a perfect square from a perfect square. So we have perfect square minus perfect square. And if we have something like that, it's also one of these where it could be really easy to factor out. Let's just go back one step and look at what happens when we multiply a difference of squares together. Okay, so when we multiply this difference of squares together, and I'm going to use grid method in here. I know I often go through really quickly, but here I'm going to take a little bit of time to go through this. 2x minus 4 and 2x plus 4. This is 4x squared. This is 8x. This is negative 8x, and this is negative 16. So when we multiply 4 and 4 together, 4 times 4 is a perfect square, but we have a negative because one's a negative. This is a perfect square, and these two are exactly the same except one is positive and one's negative. So it actually cancels out, and we get 4x squared, should be an x, minus 16. Both are perfect squares. One is positive, one is negative, and this is again what we call a difference of squares. It's a bit of a different way of solving there. If we want to take a look at just a generic way of doing that, we have, if we have like ax squared minus c, so we're missing that b term, we take the square root of a times x, and then we take the square root of c, and we're adding, and then we do the same thing, but we are subtracting. So let's do a couple of quick examples as to what this is going to look like. And again, we can go through pretty quickly. 49 is a perfect square, so this would be 7e, and 64 is a perfect square, so we're going to do 8. Now we have to do the other one as well. In this case, it's going to be minus 8. And that would be factoring out a difference of squares. Something like this here, w squared is a perfect square, so it's w. And 1 is a perfect square, so we're going to add 1. And then we're going to do the same thing, and we're going to subtract 1 at the same time. And so those are the factors for a difference of squares.